Alright, so the next node, okay, we're actually going to be taking off this node next. So we're going to be visiting D from F. So D comes off from F, and from D we can look over, we can see E, we can look over, we can see G. Note that we can also look over and see A and B, but they are already visited. So we don't add them to our edge list. So we have E and G. Now, so in our list we now have, that's gone. We have E from D, G from D. Then those are the new things. Then we're going to copy down the things that we didn't use before. That's G from F. Then D from B. So E comes off next from D. Okay, so hold on. We did visit D, so that's the next thing that happened. And then we're visiting E from D. So from E, and try
You discovered it's not bright enough, sir.
What's that?
You discovered I'm not bright enough. E, G, and D.
Thanks. Now from E, we can see G, H, and C. So we're going to discover G, H, and C. So those nodes will then be added. G from H from E, C from E. And then we add the things that we didn't get rid of first. These come down. G from D, G from F, D from B, and G from A, E from A, C from A. So we've moved over from D to E. So this fellow is really exploring through a graph. And the next place that this fellow will go is node G. Let's go from E. So the new nodes from E would be, sorry, from G. The vector moved on. Would be just H. So we have a new edge which is H from G, and that's going to be tacked on in front of all the other things that were there before. H from E, C from E, G from D, G from F, G from D from B, D from A, and G from A. Then we have E from A and C from A. So next one comes off H from G, and from H the only thing we can discover that's not already in the visited list is C. So we have C from H added. Then the rest of them that were there before. H from E, C from E, G from D, and G from F, D from B, D from A, from A, E from A, and C from A. So C from H comes off. So we've actually done the traversal from H to C. And then from C, there's no other node that's there to be discovered. So we'd, well, no, the process after that, we wrote a board space, but the process after that would involve taking things off the list to try to go to any node that was not yet visited. We would find out that every single node was visited, so all of these would be ignored when it's popped off. So, which is why that other approach of crossing out things, that's when I discovered that I figured out that I don't need that other edge there. That actually works. But if you're seeing this for the first time, I prefer to keep it in there, and then we can make it easier to clean up later on. This particular example doesn't have much of the backtracking happening. Alright, but we are going to do a breadth first search. Now, there's one more thing that you may want to be able to do with this, and that's build the depth first search tree. We can track to see where nodes were discovered from. H was discovered from G, C was discovered from H, G from E, E from D, D from F. With that information, we can draw the tree. In this case, it works out to be just one straight line through.
You're gonna draw it based on the visited.
We could draw it from this information here.
Okay.
So in this case, the DFS tree would look like A, B, F, D, to E, G, tempted to modify the graph so you see another scenario, but let's just do the breadth first search and move on.